pKa is equals to what you can do, minus log of Ka. What is that? Minus log of see, you are writing pH means what? Minus log of ఇక్కడ ఏముందో అది రాస్తున్నారు కదా, H ప్లస్. Similar to if I say pKa minus log of this above one you put here. Anything, for example Pa I am asking, minus log of A, that's it now. Okay, so what is the pKa value we will get from this? pKa equals to minus log of 10 power minus 5. So మీకు ఒక ట్రిక్ చెప్పిన, if H plus ion concentration is 10 power minus x, then pH equals to x. Same అదే స్టోరీ ఇక్కడ కూడా అప్లికేబుల్ అవుతుంది కదా. So it will be pKa will be 5. Up to here it is clear. So 1/2 5 minus log C, 10 power minus C means what? Concentration. So how much it is? 1/2 5 minus of minus 10 log 10 power x means you can write it. So minus minus plus. So how much it is? 7/2 3 point. So this is how you need to calculate pH of a weak acid. Everyone got this? Yes. Next one. You want to write? Yeah. So you can write. Next, what about salt hydrolysis formulas we discussed? See, if a salt that is formed by strong acid plus strong base, like NaCl is a salt, what is the pH of that salt solution? Neutral. It is 7 only, neutral. Okay, but if the salt is formed from strong acid plus weak base, the resultant salt solution also acidic, because what is strong here? So now pH formula is what? 7 minus something, 7 minus half pKb plus log C. Okay, so now a salt is formed from strong base weak acid, basic. Now how can you calculate that? 7 plus half pKa plus log C, that's it. Okay, if a salt is formed from combination of weak acid and weak base, it cannot be neutral. It depends on what? Their pKa and pKb values. Okay, sir, why pKa pKb values అని మీకు అనిపించచ్చు. నేను స్ట్రాంగ్ యాసిడ్ అన్నప్పుడు NaCl ఎగ్జాంపుల్ చెప్పినప్పుడు నేను ఏమంటున్నా, NaOH ప్లస్ HCl. If you take them, they are 100% dissociate na. These will undergo 100% dissociation. That's why resultant NaCl solution, salt solution pH will be equals to 7 only. That will not get hydrolyzed. Is salt solution. But if I take ammonium acetate solution, ammonium acetate. So ammonium acetate solution, you tell me this is salt solution or not? So how this salt solution is formed? అరే చూడండి, అమోనియం ఎసిటేట్ అంటున్నా. ఆల్వేస్ నెగిటివ్ పార్ట్ కమ్స్ ఫ్రమ్ యాసిడ్, పాజిటివ్ పార్ట్ కమ్స్ ఫ్రమ్. సో నౌ దిస్ ఎసిటేట్ అయాన్, వాట్ ఈస్ దట్? COOH. దిస్ ఇస్ అన్ యాసిడ్ ప్లస్ NH4OH బేస్. సో వీక్ యాసిడ్స్కి ఏముంటుంది? Ka. సో దట్ ఈస్ కన్సిడర్డ్ యాజ్ pKa హియర్. వీక్ బేసెస్ విల్ హ్యావ్ Kb, కన్సిడర్డ్ యాజ్ pKb. సో ఈ pKa pKb వాల్యూస్ని బట్టి we will decide whether the salt solution will be acidic or basic. Okay, so now what is that final formula I told you? pH equals to 7 plus half pKa minus pKb. That's it. Okay, so this is the 3 formulas to be remembered. Next one, ఇప్పుడు ఒక క్వశ్చన్ ఇస్తారు, write it fast. Yes ma'am, fast. ఏ సాల్ట్? ఇప్పుడు ఆ సాల్ట్ అసిడిక్ అవుతుందా బేసిక్ అవుతుందా అని ఎవరు డిసైడ్ చేస్తారు? దీస్ వాల్యూస్ pKa and pKb values depends. Okay na, so ee values chepte whether we can decide it as acidic or basic. Like if it is coming like 7 plus some value, it means 8 వచ్చింది అనుకో pH, so resultant solution will be basic. So మరి ఈ values ఎలా సార్ అంటే they will give in the question. That's it. Over up to here? Okay. Next one. Look at this question once. Ka values of A, B, C are given like this. The correct order of their acidic strength. Ka value ante enti? Acid dissociation constant. What is that? So higher the acid dissociation constant means what? అప్పుడు మనం ఈక్విలిబ్రియం కాన్స్టెంట్ గురించి డిస్కస్ చేసినప్పుడు అప్పుడు ఏం చెప్పినా, సో గ్రేటర్ ఈజ్ ద ఈక్విలిబ్రియం కాన్స్టెంట్ వాల్యూ, ఇట్ మీన్స్ మోర్ ఫార్వర్డ్ రియాక్షన్ ఇట్ ఈస్ టేకింగ్ ప్లేస్. ఓకే, హియర్ యాసిడ్ డిసోసియేషన్ కాన్స్టెంట్ ఈస్ నథింగ్ బట్ ఈక్విలిబ్రియం కాన్స్టెంట్ ఓన్లీ నా ఫర్ దట్ యాసిడ్. సో నౌ హయ్యర్ ద Ka value means I can say more acidic it is, more forward it is moving, more H plus ions it is releasing. So now tell me out of this which is stronger acid, A, B, C? Greater value is where? ఇందులో ఏది biggest value? See 10 power minus 4, 10 power minus 10, 10 power minus 8. So Ka value great for which one? A. So A is stronger than C. That's it. Is this clear? This is how you need to decide acidic strength, looking at their Ka values. Okay, so greater Kb value means? So now remember these are the values. Acidic nature, acidity directly proportional to Ka, acid dissociation constant. Okay, and now pK ante ela rastunnamma, pK equals to minus log of Ka అని అంటున్నాం. See how they related Ka and pKa? Like minus na more Ka, lower is a pK. So more acidic substance, more acidic compound have greater Ka and least pKa. Is this clear or not what I am saying? Ka, pKa, acidic nature, how they related? Is this clear or not? అర్థం కాకపోతే చెప్పండి మళ్ళీ. Let us say HA is an acid. What is this? HA అనేది ఒక acid. Like HCl is an acid, no? Like that HA is an acid. Okay, how it will dissociate? H plus A minus. Okay, ఇప్పుడు దీని యొక్క acid dissociation constant how you will write? Ka is equals to concentration of H plus multiplied with concentration of A minus by HA. Like this we will write, no? So acid ante enti? It should release more amount of H plus ions. So it means greater is the value of this numerator. For an acid, if I say an acid is very strong, its H plus ion concentration should be more. So it means greater H plus ion concentration, greater K, numerator means greater will be its numerator ఎక్కువ ఉందంటే ఇది కూడా ఎక్కువ ఉన్నట్టే కదా దీని వాల్యూ. సో I can simply say Ka value is directly proportional to acidic nature. Okay, and Ka, pKa, how they related? Like minus log Ka na, so inversely. So can we relate it like this? Yeah. So next one more thing, basic nature or basicity or basic nature directly proportional to base dissociation constant Kb, and this will be inversely proportional to pKb. Is this clear everyone? Yeah. So ఈ క్వశ్చన్ లో this question contains Ka values. Next మనం ఆర్గానిక్ వెళ్తాం. So there they will say for the given 4 acids arrange them in the pKa order or pKb order. What is your answer? Many questions are there like that. So pKa means what? Least acidic, more pKa. Least acidic, more. That's it. Okay, we will do that. No worries. Now I don't want to touch it. Okay. అరే దీనికి ఆన్సర్ చెప్పండి రా, ఐ విల్ బి హ్యాపీ ఫర్ దట్. దిస్ వన్ I know you can see. At least NH4Cl is a salt. That solution is made up of what? That salt solution. Strong acid and weak base. So pH definitely acidic. Less than, what is your answer? Less than 7. Less than 7. Wow, you want? We cannot say exact value now. We can say it might be less than 7. It is acidic or not? Acidic means less than 7. This is perfect one. Okay, is this clear everyone? First of all, ఓకే ఈ క్వశ్చన్ చేయండి. What is the relative basic strength of ClO2 minus, ClO3 minus, ClO4 minus? Okay. Yes, A option. How many of you are A? One explanation from anyone. It is correct. See, we have studied about Bronsted acid base theory. Do you remember? What is that? Like if we have an acid like HCl, then okay, proton adds in HClO2, next HClO3 and HClO4. Like this we have now. Please listen. Like this we have now. So after releasing H plus ion only we will get ClO2 minus, ClO3 minus, ClO4 minus. Okay. So if you remember in periodic table, I told you about acidic nature and oxidation state concept. Greater the oxidation state, greater is the acidic nature. So where do we have more oxidation state? Here plus 7, plus 5, plus 3. So which is having greater oxidation state? This one. So this oxo acid is highest acidic. So this is the order of acidic nature. What is this? Acidic nature. Okay. Now if this is an acid, after releasing H plus ion, the remaining part is called conjugate base. This is also a conjugate base now. This is also a conjugate base. Okay. If acid is strong, its conjugate base is weak. What I am saying? If acid is strong, its conjugate base is weak. Okay. Write this statement under the Bronsted acid base concept. A strong acid conjugate base is weak. What I am saying? A strong acid conjugate base is weak. Now in the reverse way, a weak acid conjugate base is right now. So out of this, which is strong acid? So strong acid conjugate base will be, so this will be weak now, this will be strong. So which is strong base out of this anions? This is the basic nature order, this is the acidic nature order. Is this clear? Yeah, make a note. Do you have any confusion in this again? If you have, please tell me, I will repeat. Yes. Okay. First of all, find their oxidation states. Greater the oxidation state, stronger is the acidic nature of that compound. So who is more acidic? Okay, done. Acidic nature is done. Now a strong acid conjugate base is weak. ఒక కాంపౌండ్ స్ట్రాంగ్ యాసిడ్ అన్నాం అనుకో, దాని యొక్క కాంజుగేట్ బేస్ అనేది వీక్. కాంజుగేట్, ఇది యాసిడ్, దాని కాంజుగేట్ బేస్ అనేది ఇప్పుడు ఏమవుతుంది, వీక్. లైక్ దట్ అసిడిక్ నేచర్ ఇస్ దిస్ ఆర్డర్, basic nature will be reverse of it. That's what I have written. Clear or not? అర్థమైందా కాలేదా? Alright. Answer me for this one. Already we did in the classroom. Perfect. Next one, which acid among the following has highest pKa? First of all, these are halogen acids now. Halogen acids, what happens down the group, acidic nature? Increases or decreases? You just tell me, which is strong acid out of all this? See, HF. HF. Okay, so down the group, what happens to the halogen size? Small, little bigger, little more bigger, and very bigger. Okay? Now look at this side. Hydrogen size is same. So now tell me, a small size hydrogen atom, large size anion. What about their orbital overlapping? It's a very weak overlapping now. It means that bond between H and I will be very weak. So that bond is easily breaking. So it means bond easily breaking means H plus ion will be easily given out. So who is strong acid? HA. So down the group, halogen acidic nature increases. So who is strong acids? Strong acid here? HI. Don't say HCl anymore. HI is stronger than HBr, and next HCl, and least is HF. This is the acidic nature order. Okay, now answer me, what about their pKa order? pKa order, how they are related? Just now we given. Acidic nature directly proportional to Ka, inversely proportional to pKa. So they are asking for pKa, so reverse of this. So highest is for which one? So what's your answer? Clear everyone? Yes, done. Next. Next one. You know buffer solutions? Having never heard buffer solution? Yes. So I will tell you one simple. Okay. వినండి. See, లెమన్ జ్యూస్ తాగుతారా తాగరా మీరు? తాగకపోతే సైలెంట్గా ఉండండి, తాగిన వాళ్ళకి. See, when we are taking any acidic juices, if there is any change in the pH of our body fluids? There is no change. See, if there is any change in the pH of our blood or any body fluids, we'll get ill, like we'll feel sick. But it's not happening because there is no change in the pH of our body fluids even when we are taking the acidic juices like lime, lemon juice or whatever it is. Okay, so now what makes that resist in the pH value in our body? So there is a system called buffer system in our body which resists the change in pH. When we are taking any acidic juice, there is no change in the pH. Okay, so now what do we mean by buffer solution? Tell me. The solutions which resist change in pH by addition of small amounts of acids or by addition of small amounts of bases or upon dilution. We can call those solutions as buffer solutions. Okay, so now what exactly buffer solution example means? See, this is of two types. How many types? Two types. So okay, once again define buffer solutions before I am giving the example. The solutions which resist the change in pH. It means there is no change in the pH by addition of small amounts of acid or small amounts of base. Those solutions are called buffer solution. Generally ఇప్పుడు నా దగ్గర వాటరే ఉందమ్మా ఈ బీకర్లో, దీనికి నేను లెమన్ జ్యూస్ యాడ్ చేస్తే ఏమవుతుంది? ఇచ్చేయండి సార్. సో దీని pH ఏమవుతుంది? వాటర్ మీన్స్ 7. When I add this citric acid lemon juice, it pH falls to around less than 7, like it might be 3, 4, 5 like that, right now. But if I add same lemon juice to the buffer solution, there is no change in the pH. This solution now, that present solution present in the buffer beaker is called as buffer solution. Is this clear or not? Yes. Yeah. So once read the definition once again. Solution that resists the change in pH when a small amount of acid or a base is added. Okay, next, now types of buffers. It is of three types. First one is acidic buffer, next basic buffer, next salt buffer. So acidic buffer ante enti? Let me give you the example. See, whenever I say buffer, you should get two things in your mind. One is weak electrolyte plus salt of that weak electrolyte with a strong electrolyte. What I am saying, buffer means what should come into your mind? Weak electrolyte, salt of weak electrolyte with a strong electrolyte. I will give one simple example. First, acidic buffer. What is this? Acidic buffer. So in acidic buffer, acidic I am saying now, you take a weak acid. Give one weak acid example. Acetic acid you take. Plus salt of this weak acid. What I give in the general formula? Weak electrolyte plus salt of that weak electrolyte, strong electrolyte. It means this is the weak electrolyte. Then salt cheppandi. Salt ante it should be acetate ion plus something like Na plus ion. See, weak electrolyte, the salt of that weak electrolyte with a strong electrolyte. See, what is this mean? Acetic acid is there. If I add NaOH, what happens, ma? Acetic acid plus NaOH, what it will give you? CH3COOH plus water only, no? Okay, this is nothing but weak acid plus salt of that weak acid with a strong base is considered to be acidic buffer. What is it? Acidic buffer. Now, ఇది అర్థమైతే you just tell me in the same way, how can you give the basic buffer? Basic buffer. అరే నేను acidic buffer అన్నప్పుడు ఏం తీసుకున్నా? Weak acid. సో basic buffer అన్నప్పుడు ఏం తీసుకోవాలి? అరే చెప్పండి. Weak base plus salt of that weak base with a strong acid. Okay, so now this NH4OH upon treating with a strong acid, what is the strong acid? Here I can take NH4OH plus HCl. So now what is the salt formed from it? NH4Cl. So this combination is called now basic buffer. Is this clear? Acidic buffer and basic buffer? Okay. Now I will check whether it is clear or not with one or two examples. I need to check the questions first, where it is. Okay. See, I just now I asked you a question about body fluid, pH of body fluids. Now read the question. The buffer solution system which helps to maintain pH of blood between 7.6 to 7.42. So what is it? So our body contains this buffer system. What is this? Carbonic acid and bicarbonate. What is it? See, carbonic acid is a weak acid. What I am saying, carbonic acid is a weak acid. So this, if I remove proton from here, this is a bicarbonate ion formed now. So this is nothing but that salt of weak acid I am saying now. After removing proton, this is the thing we will get. So this system is called now buffer system. So this is an example of acidic buffer or basic buffer? Acidic buffer. Fine. For this question, what is your answer? A. This question is done. Now let us diagnose this with some other examples. Like, see, tell me, what about this salt solution? What type of base? What about this one? What about this? Acidic buffer or basic buffer? What about this? Buffer like it should be called as salt buffer. So salt buffer is formed by combination of weak acid, combination of weak acid plus weak base. See, correct. See, weak acid plus weak base, what it will form? Salt. ఇప్పుడు weak acid example ఏంటి? Acetic acid. Weak base example NH4OH. What is the salt formed from it? So this is a salt. So this is a, which buffer it is? Salt buffer. Clear everyone how to identify buffer systems? Yeah. Next one. Let me check that question where it is. Look at this. Which of the following does not form a buffer solution? Tell me, first one will forms buffer solution or not? First of all, tell me, what is this ammonia weak, what? Weak base. This one? So weak base is strong acid. Strong acid. So now, what type of buffer we have possibility? Basic buffer. In order to make basic buffer, who should be more first? See, basic buffer combination ఎలా ఉండాలి చెప్పండి? There should be weak base plus salt of that weak base plus ఫస్ట్ మీరు ఏం చేయాలంటే మనకి సాల్ట్ ఫామ్ అవుతుందా కాదా చూసుకుందాం. ఇక్కడ ఎన్ని మోల్స్ ఉన్నాయి చూడండి, 2:1 మోల్ రేషియో అని అన్నారు. సో 1 మోల్ like 2 moles of ammonia plus 1 mole of HC. This gives you, which is limiting reagent out of this? HCl. So we'll get 1 mole of NH4Cl. Out of these 2 moles, how many moles reacted? 1 mole. How many moles remained unreacted? ఇప్పుడు ఇంకో 1 mole ఉంది కదా. సో నో వాట్ ఈస్ ద రిజల్టెంట్ మిక్చర్? ఇంకా మిగిలింది ఏమున్నది చెప్పండి మనకి? 1 mole ammonia plus 1 mole NH4Cl. That's it. Now this is a resultant mixture. No? Yes or no? Up to here? Yeah. So can I say this resultant mixture buffer solution or not? See, a weak base plus salt of that weak base with a strong acid. So this can be considered to be. So ఇది ఎందుకు ఇంత స్పెసిఫిక్ ఎక్స్ప్లెయిన్ చేస్తున్నా? ఇట్ మీన్స్ దే విల్ గివ్ యూ లైక్ దిస్. దే విల్ బి ఆస్కింగ్ యూ విచ్ ఆఫ్ ది ఫాలోయింగ్ డస్ నాట్ ఫార్మ్ బఫర్. ఇన్ ఆర్డర్ టు ఫార్మ్ బఫర్, హూ షుడ్ బి టేకెన్ మోర్? If I say weak buffer, basic buffer, the basic compound should be, weak base should be taken excess. If I say acidic buffer, weak acid should be taken excess. If I take both acid base equal amount, they won't form buffer. Okay? If I take strong electrolyte excess, they also won't form buffer. So now tell me whether first option forms buffer or not. Which type of buffer it is? Perfect. Next, this one you tell me. 2:1 ratio. Which type of buffer is possible here? Perfect. This one you tell me. 1:1 means neutral only. It won't form any buffer. So remove this. This one. See, already a salt plus weak base. Weak base plus salt of that weak base with strong acid. Which buffer it is? Are what we have ma? Base, weak base na, so you should say basic buffer. Clear? So what is your answer for this question? C. Is this clear everyone? Yeah. Next. Okay. Now how to calculate pH of a buffer? What I am saying? How to calculate pH of a buffer. So for an acidic buffer, you should say like this: pH equals to pKa plus log concentration of salt by acid. Once again, pH equals to pKa plus log concentration of salt by acid. Okay, the derivation, all those I am not giving you, direct formula I am giving you. Okay, next pOH, if I say pH అన్నప్పుడేమో pKa, pOH అన్నప్పుడేమో సేమ్, ఈ పార్ట్ సేమ్ అక్కడ కూడా సాల్ట్ బై, ఇక్కడ సాల్ట్ బై, దట్స్ ఇట్. రైట్ ఇట్ ఫాస్ట్. బేసిక్ బఫర్ ఇచ్చి pH క్యాలిక్యులేట్ చేయమంటారు. దే విల్ గివ్ యూ బేసిక్ బఫర్ అండ్ ఆస్క్ యూ టు క్యాలిక్యులేట్ pH. వాట్ యూ విల్ డూ? ఫస్ట్ యూ డూ pOH. pH ప్లస్ pOH ఈక్వల్స్ టు, అది యూజ్ చేసి pH క్యాలిక్యులేట్ చేయాలి. ఓకే, ఐ విల్ గివ్ యూ వన్ క్వశ్చన్. You what is a buffer range? What they will ask you? Buffer range. A buffer shows its efficiency. Listen, buffer shows its efficiency only in this range. See, what is the formula you have written for both of them? For acidic buffer you have written pKa plus log salt by acid. So now pKa plus something you have written. So buffer range is what? pKa plus 1 and pKa minus 1. So in this, for example, pKa value for that particular weak acid, I am saying 4. Now what is its buffer range? 4 minus 1, 3, 2, 4 plus 1, 5. This is the buffer range for that particular acidic buffer. Same story applicable for basic buffer also. So you just remember pKa plus 1 to pKa minus 1. For basic buffer it will be pKb minus 1 to pKb plus 1. Done? Next. Okay, see. Find this. Fast. What is the pH of 10 liter of a buffer solution containing 0.01 molar ammonium chloride and 0.1 molar ammonium hydroxide having pKb as 5? How can you do this? Basic buffer or acidic buffer? See, ammonium chloride and ammonium hydroxide, basic buffer. So what should we calculate? pOH. pKb plus salt by base concentration. Perfect. So pOH will be now 5 plus, what is the salt concentration? So 10 power minus 2. This one log. This one 10 power minus 1. So 10 power minus 1 here. Sorry. So how much it will be? pOH equals to 5 minus 1. So it will be 4. pOH is 4, but they are asking you pH. Now how can you do? pH equals to 14 minus pOH. So 14 minus 10. We got the answer now? Perfect. Done, everyone done? Yeah. Okay. Next one is, last concept of this chapter is solubility and solubility product. What is that? Solubility and solubility product. See, what do we mean by solubility and solubility product? Means, see, there is a salt like this, AX, BY. What is this salt? What exactly AX, BY means? See, I am writing AgCl. This is cation, this is anion. So our A is cations, B is, so what is the ion number here we have? 1. Here also 1. X is 1, Y is also 1. Like that, Ag2Cr, otherwise Ag2CO3 is there. So now what is the X and Y values, you tell me? Ag, 2 Ag plus ions are there, 1 carbonate ion is there. So here what is the number here we have? 1. For this what is the number we have? 2. X is 2, Y is 1. Like that I am generalizing all the salts like this. AX, BY. Getting what I am saying? AgCl kadamma. How it will dissociate? Ag plus Cl minus. So how many Ag plus ions are there? One number ikkada rayali. How many chloride ions are there? ఆ వన్ నెంబర్ ఇది రిప్రజెంట్ చేస్తుంది. అర్థమైందా? ఫర్ ఎగ్జాంపుల్ ఐఎమ్ రైటింగ్ AlOH twice. AlOH twice. So what is the numbers here, X and Y numbers? Here A is nothing but our aluminium. B is nothing but OH. OH పైన ఎంత ఛార్జ్ ఉంటుందమ్మా జనరల్గా? -1. Okay, how many OH ions are there? 3 OH ions, and ikkada ఎంత ఉంది నెంబర్? అది 1 aluminium, that should be with +3 charge. Ikkada X, Y are nothing but 1, 3. Like that I am generalizing all salts into this format. Okay, so now when I place a salt in the water, what happens? It will get dissolved in that water. Okay, but what I am saying, saturated solution, you know, saturated solution ante enti? Sugar తీసుకోండి ఇప్పుడు. You have water, you are keep on adding sugar, you are stirring it. What happen? First it will dissolve easily, but if you keep on adding it, it will stop at a point that further if you add sugar it won't get dissolved. That the maximum amount of sugar that can be dissolved in the water is called saturated solution. A saturated solution form అయినాక if you add more sugar, will it dissolve? No, it will remains undissolved. That solution you should call it as super saturated. What is that? Super saturated. The maximum amount of solute that can be dissolved is called saturated solution. Before saturation point untadi kada, that you should call it as unsaturated solution. What is that? Unsaturated. 3 terms I told you. Unsaturated, saturated, super saturated. So saturated means what? Maximum amount of solute that can be dissolved. Super saturated means if you add extra amount that remains precipitated only, undissolved only. Okay, now unsaturated means yeah, we can dissolve little more amount of substance that can be dissolvable. From unsaturated to we'll get saturated, from saturated we'll get you got this. Okay, now my discussion is at that saturated point. Where is my discussion now? Saturated. So now these compounds will get dissolved. When it is dissolving, like NaCl, if it is dissolving, we'll get Na plus Cl minus. No? Like that we are going to get A plus B minus. But how many A ions are there? X. So you should write it as X, A. How many B ions are there? Plus Y, B minus. Okay, but overall molecule looks like neutral. No? You should write this charge on this place, this charge on this place. So Y, X. Is this clear? Everyone what I am doing? Clear or not? A ions ఎన్ని ఉన్నాయి? X. B ions ఎన్ని ఉన్నాయి? So like that you write. Charges you should balance by crisscross methods like this. Let us say S amount of salt is there at a time t0. ఇనీషియల్ కేసు ఎంత ఉంది? S అమౌంట్ ఉంది. డిజాల్వ్ ఎంత? 0 అయిపోయింది. నేను ఇంకా డిజాల్వ్ చేస్తున్నా, వాటర్లో స్టీర్ చేస్తున్నా నాకేమైంది? ఒక ఈక్వలిబ్రియం సిచ్యువేషన్ వచ్చింది. ఈక్వలిబ్రియం సిచ్యువేషన్ అంటే ఏంటి? That is the maximum amount of this salt can be dissolved. Okay, అది ఎంత ఉంటుంది అని అంటే ఎస్, ఇక్కడ ఎంత ఉంది నెంబర్ ఎక్స్ఎస్, ఇక్కడ ఎంత ఉంది వై ఎస్ అమౌంట్. లైక్ దిస్ యూ షుడ్ రైట్. సో నౌ వాట్ ఈస్ ద ఈక్విలిబ్రియం కాన్స్టెంట్ ఐ కెన్ రైట్ ఫర్ దిస్? ఎట్లా రాయాలి ఈక్విలిబ్రియం కాన్స్టెంట్ అంటే? ఏ ప్లస్ వై ఉంది కదా, దానికి కోఫిషియంట్ ఎంత? పవర్ ఎక్స్. ఇక్కడ ఏముంది? బి మైనస్ ఎక్స్ పవర్ వై. ఓకే, ఏ యొక్క కాన్సన్ట్రేషన్ ఎంత? ఎక్స్ఎస్ టు ద పవర్ ఎక్స్, వైఎస్ టు ద పవర్ వై. సో ఇప్పుడు మనం సాచురేటెడ్ సొల్యూషన్స్ గురించి మాట్లాడుతున్నాం కదా. సో దిస్ వాల్యూ is called as a saturated solubility product of that saturated solution. What is this called? Solubility product. Solubility product. So దీన్ని సింప్లిఫై చేయండి. x power x, y power y, s power x plus y. So ఇది ఎందుకు ఇచ్చానంటే you will get now. Like this you are writing now. So now tell me the same story you apply it for AgCl and tell me how it will dissociate ma? Ag plus Cl minus. Now I am asking solubility product of this AgCl. How you will write? Ag plus ion, Cl minus ion. Now let us say S amount of salt is taken initially. After some time t, it will be how much? 1s. This is also so you can write it as 1s power ఎంత ఉంది 1. ఇక్కడ ఎంత power. So what you can write? Solubility product will be Ksp equals to S into S, S square. Now in the question they may give this S value or they may give this ఏదో ఒకటి ఇచ్చి ఇంకో దాన్ని క్యాలిక్యులేట్ చేయమంటారు. సో ఇఫ్ దే గివ్ S value you put here you will get the Ksp, or they may give you Ksp, they will ask you S. So what you can do, S is equals to root over, that's it, like this. So now what is the generalized formula I am giving you? X power x, y power y, x power s power x plus y. Okay, ఇది కూడా one of the important topic but most students skip. Okay, let me check the question related to this. ఇక్కడ చూడండి, read this question fast. The solubility product of a sparingly soluble salt, which salt they have given? A2B is this much. Ksp ఎంత అన్నారు? I am writing it as 32 into 10 power minus 12. Can we write it like this? Yeah. Next, its solubility product, like they are asking solubility. By giving solubility product, they are asking you what you will do now here? A2, sorry, 2 A ions, 1 B ion. That's it now. ఇక్కడ 2 ఉంది కాబట్టి 2 A ions, 1 B. Now neutralize them. It should be positive, it should be negative. But how much negative it should be? See, this here, this here. Okay, over up to here. Next మీకు a simple tricky way చెప్పిన చూడండి. Ksp equals to x power x, s power x plus y. చెప్పండి, x ఎంత? 2 power 2 4, y ఎంత? 1, s ఎంత? 2 plus 3. అంతేనా? This is equals to Ksp. Ksp ఎంత? 32 into 10 power, so 4 8s. So we got 8 into 10 power minus 12 equals to s cube. So 8 ని నేను 2 cube రాయొచ్చా? 10 power 12 అంటే 10 power minus 4 to the power 3 అని రాయొచ్చా? 4 3s ఎంత? So I can remove this 3, this 3, this 3. So s will be now. This is your answer for the question. Check. It is there? Yeah. You write these. 2 slides. Ask like this. Okay, once again I am saying it from the beginning. What they are asking? Read it. Solubility product of a sparingly soluble salt is this much. KSP is how much? 3.2 into 10 power minus 11. I can write it as 32 into 10 power minus 12. Okay, then what they are asking us? Solubility of that salt they are asking. Okay, so KSP is given, S they are asking. That's it now. So what is the generalized formula? KSP equals to S power x power x y power y into S power x plus y. Okay, so ఇప్పుడు ఇందులో x y values ఏంటో చూసుకోవాలి మనం. What is the x value here? Y value ఇక్కడ పెట్టేసేయండి. 2 power 2, 1 power 1, S power 2 plus 1. So 4s cube. That's it. So 4s cube ni ఇలా రాసుకోవచ్చు కదా, 4s cube. Now KSP value how much they given? I am writing 3.2 as 32. It means 10 power minus 1 is taken. That is added here. 10 power minus 12. I am writing here. So 4 8s are 32. Next S power 3 అట్లనే ఉంది. So 8 ని 2 power 3 రాయొచ్చా? 10 power minus 12 ని 10 power minus 4 into 3 అని రాయొచ్చా? Yeah. So this 3 is removed. So what is the remaining part? That is your answer. అర్థమైందా కాలేదా? Okay. You write there. I will check other questions. Okay. So here one more model question is there, ma. Just listen to me here. This is the one last question from this chapter. See, again, once read the question. AgBr, solubility of AgBr having solubility product is this much. KSP of AgBr how much? 5 into 10 power minus 10. Now AgBr how it will dissociate? Ag plus Br minus. Okay. దీనికి సాల్యుబిలిటీ కనుక్కోమంటే మనం ఏం చేస్తాం? దిస్ ఈజ్ 1s, దిస్ ఈజ్ ఆల్సో s. సో s స్క్వేర్ ఈక్వల్స్ టు KSP, అందులో నుంచి s వచ్చేస్తుంది, అంతేనా? బట్ దే ఆర్ ఎక్స్టెండెడ్ ద క్వశ్చన్ విత్ దిస్. సి సాల్యుబిలిటీ ఆఫ్ AgBr హ్యావింగ్ సాల్యుబిలిటీ ప్రోడక్ట్ ఇస్ దిస్ మచ్ ఇన్ 0.2 మోలార్ NaBr సొల్యూషన్. అంటే ఇది ఎందులో ఉందంట? 0.2 మోలార్ NaBr. సో దిస్ ఎఫెక్ట్ ఈస్ కాల్డ్ కామన్ అయాన్ ఎఫెక్ట్. ఏమంటాం దీన్ని? So we have studied Chatelier principle today. So what that Chatelier principle says? Whenever we increase the concentration of reactant, equilibrium shift. Whenever we increase the concentration of product, equilibrium shifts backward. So ఇప్పుడు చెప్పండి, NaBr strong electrolyte, weak electrolyte? NaBr. See alkali metals now. So just remember. So these are covalent salts, these are weak electrolytes, sparingly soluble salts these are. Okay, that's why I am representing this as equilibrium symbol. Here I am representing complete arrow, one side arrow. So now what is the concentration of NaBr? 0.2. This is also then 0 initially, but after dissociation 0.2 because it is a strong electrolyte. Now let us say here KSP ఇప్పుడు ఎట్లా రాయాలి? నేను S00 అని రాయాలి ఇనిషియల్ లో. ఆఫ్టర్ సమ్ టైమ్ T, this will be S, this will be also S. But here we have presence of common ion ఉంది కదా. So when there is common ion, what happens is S as it is I am writing, but just for making difference I am writing S dash. What is the total concentration of Br minus we have in the solution? In the beaker we have now AgBr and also NaBr. దీనికి ఇప్పుడు నేను ఏం యాడ్ చేసిన? NaBr. Now what is the total Br minus ion concentration? S plus 0.2. To this equilibrium what I added? NaBr. So when I am adding NaBr, this Br minus ion concentration is increasing or not? అంటే Br minus కొత్తగా యాడ్ అవుతుంది కదా, అప్పుడు what happens to the Br minus ion concentration? Increases. If you increase the concentration of products, what happens to equilibrium? Shifts backward, right now. So it means the degree of dissociation of this electrolyte, the degree of solubility of this electrolyte decreases. Can I say decreases? Why? If it is moving this side, I can say increases, but it is moving. So I can say solubility of this weak electrolyte decreases upon addition of a strong electrolyte which is having common ion. Are they common ions or not? If I add a common ion, then degree of dissociation of weak electrolyte decreases. Okay, so అది ఎంత అవుతుంది అని అంటే this value you should take s plus 0.2 is there now, you should take it as 0.2 only. అంటే ఈ Br minus ion concentration will be neglected when I compare with that ion concentration. So now tell me how to write KSP now. Concentration of Ag plus concentration of Br minus. సో Ag ప్లస్ ఎంత అని తీసుకున్నాం S డాష్, Br మైనస్ నెట్ ఎంత వచ్చింది 0.2. ఇక్కడ మనకు KSP ఎంత 5 into 10 power minus 10. Yeah, so now what I can write here, see I am writing 50 into 10 power minus 11 S dash into 2 into 10 power minus 10 minus 1. Can I write like this? So minus 1, ఇక్కడ minus 11 ఉంది కాబట్టి 10 power minus 10 I can write. So 2 ones are, so S dash will be now how much? 25 into 10 power minus 10. So this is your final answer. So we have B. Okay, write these two questions. These are important. You can do, and you know, for equilibrium, don't worry like looking at the questions in your module. If you are feeling too much difficult there, so this PDF contain lot of questions, almost some 30-40 questions are there. You can solve all those questions. Okay, so it will be there in this I can say panel itself. You can load it and do it. That's it.